In the evolving landscape of network security, two concepts have gained significant attention due to their relevance in enhancing the security of modern distributed enterprises: Zero Trust and Secure Access Service Edge, or SASE. Both frameworks address the challenges posed by the increasing mobility of users and the shift towards cloud-based resources, but they approach the problem from different angles. What is Zero Trust? Zero Trust is a security model based on the principle of never trust, always verify. It assumes that threats exist both outside and inside the network. Thus, no users or machines should be automatically trusted irrespective of their location relative to the network perimeter. These are the Zero Trust Gate principles. 1. Least privilege access. Access rights are strictly enforced based on the necessity of the role. This minimizes each user exposure to sensitive parts of the network. 2. Microsegmentation. The network is divided into small, secure zones. Each zone requires separate authentication and authorization, which limits the lateral movement of an attacker within the network. And 3. Continuous verification. The security posture and authentication of users and devices are continuously verified before granting access to resources, regardless of user location or asset location. Zero Trust relies on strong authentication. By integrating a strong authentication measures, a zero trust approach effectively reduces the attack surface, limits the potential impact of breaches, and enhances overall security posture by ensuring that only authenticated and authorized entities can access network resources. This continuous verification aligns with the overarching principles of zero trust that assumes there is no implicit trust granted to assets or user accounts based solely on their physical or network location. How does ZTNA achieve its goals? In the framework of zero trust network access, ZTNA, the concepts of the control plane and data plane play pivotal roles in securing network access. These two components, while interconnected, serve fundamentally distinct functions that are essential for enforcing the zero trust principle of never trust, always verify. The control plane acts as the brain of the network security architecture under ZTNA. It is where all decisions about network access are made, based on a strict adherence to security policies. This component handles the authentication and authorization of users and devices, ensuring that every access request is rigorously verified before access is granted. The control plane continuously evaluates the security status of devices and the credentials of users, dynamically adjusting access permissions as needed to maintain a secure network environment. Conversely, the data plane is concerned primarily with handling and transmission of data once access permissions have been granted by the control plane. It operates at a lower level, focusing on the efficient and secure transfer of data packets across the network. The data plane implements the decisions made by the control plane, ensuring that data flows between the correct sources and destinations with robust measures in place for encryption and ongoing security. The interconnection between the control plane and the data plane is critical for the effective implementation of zero trust. While the control plane ensures that all access is contingent on a stringent verification, the data plane maintains the integrity and confidentiality of data as it moves through the network. This separation of duties allows for enhanced security and better performance as each plane focuses on its specific role without being bogged down by the responsibility of the other. Understanding these roles and their interplay within a zero trust architecture is crucial for organizations aiming to protect their networks from internal and external threats. By effectively leveraging both the control plane and the data plane, organizations can ensure a robust security posture that dynamically adapts to evolving threats and maintains a strict control over network access and data flow. Zero trust capabilities. These are the four main capabilities of zero trust. One, adaptive identity management. This involves continuously assessing and adjusting authentication based on the user's or device's context and behavior. It enhances security by requiring a stronger authentication in higher risk. Two, threat scope reduction. Employing strategies such as microsegmentation and the principle of least privilege, this capability reduces the avenues available for attackers, limiting lateral movement within the network and minimizing the potential impact of breaches. Three, policy-driven access control. Access decisions are made based on detailed policies that consider the identity, context, and compliance status of the requester. This ensures that only authorized and compliant entities can access specific network resources under secure conditions. And four, implicit trust zones. While zero trust advocates for minimal trust, practical implementations may involve zones with varying levels of trust, particularly around sensitive data. Managing these zones effectively is crucial for maintaining security integrity across the network. These components work together to fortify networks against internal and external threats by constantly verifying trust and adjusting access controls dynamically, embodying the zero trust principles of never trust, always verify. This picture explains basically how the zero trust components work together. So first we have the control plane and the data plane. So we have a subject, which is basically uh, it's either a user or it could be an application or a process that it's that needs to access data, needs to access some stuff. Now, that subject needs to access that data using a device. This device under the zero trust should be considered untrusted, independently of whether the device is externally or it's inside the network. It doesn't matter where it is. In the traditional world, in the traditional networking mindset, if the device is inside the network, is considered trusted. But in the zero trust mindset or methodology, all devices and entities and subjects should be considered untrusted. Now, here is where the control plane. So the control plane has a policy engine and it has a policy administrator. This is where all the policy decisions are made. At this point, the control plane needs to make a decision to see whether this identity, whether it is this individual and this device are actually real, if they are authentic, if they actually are who they are saying that they are. So the control plane needs to make some decisions, right? And then the data plane will do the enforcement of those points. So basically they work together. Once the decision is made that this subject and devices are trusted, then they can access the enterprise resource, whether it is a database or a web app or some files, whatever it may be. So this is in a nutshell how this zero trust components work. Now, of course, it is a lot more complex than this. So I'm just trying to make it simple to understand how this works. Now that we just went through in basic concepts and explanation what zero trust is about, what is then SASE? Secure Access Service Edge, or SASE, is a network architecture that integrates comprehensive wide area network capabilities with multiple security functions into a single unified cloud service. Developed to address the evolving needs of modern businesses with distributed workforces and cloud-based resources. SASE combines networking and security into a holistic service delivered directly from the cloud. Here is a list of the main SASE components. One, the SD-WAN, or the software-defined wide area network, which optimizes traffic routing across multiple transport services, enhancing network agility. Two, secure web gateways, which filters and blocks malicious web traffic, enforcing safe web access and company policies. Three, Cloud Access Secure Brokers, or CASB, which serves as security policy enforcement between cloud users and providers, enhancing cloud security and compliance. Four, Firewall as a Service, which provides scalable and centrally managed firewall capabilities from the cloud, adjusting to traffic demands. Five, Zero Trust Network Access, or ZTNA, which grants access based on a strict identity verification with detailed control over who can access what within the network. Six, Data Loss Prevention, or DLP, which monitors and protects sensitive data from unauthorized access and breaches, securing data at rest, in motion, and in use. And seven, threat prevention, which utilizes tools like IPS and anti-malware to detect and mitigate threats in real time. So what is the relationship between ZTNA and SASE? The relationship between ZTNA and SASE is that ZTNA forms a core part of the SASE framework, while SASE provides the architecture and the delivery model, integrating network and security services via the cloud. ZTNA adds the critical capability of secure zero trust access control. This integration means that within a SASE model, ZTNA not only secures access based on identity and context, but also benefits from the scalability, performance, and simplified management that SASE offers. Together, ZTNA and SASE represent a comprehensive approach to securing modern distributed enterprises where users, applications, and data can reside anywhere. SASE's broad framework enables the practical and efficient implementation of ZTNA principles, ensuring that organizations can adapt to the evolving security landscape without sacrificing performance or user experience. To learn more about Zero Trust, ZTNA, SASE, and all these concepts, one of the best resources out there is the Open Group. The Open Group is a global consortium that enables the achievement of businesses' objectives through technology standards. Founded in 1996, it provides a neutral environment where members from various industries can meet, share ideas, and collaborate on developing open vendor neutral technology standards and certifications. The Open Group is well known for its development of standards like the Unix systems and the Enterprise Architecture Framework, TOGAF, the Open Group Architecture Framework, among others. Their standards ensure interoperability and guide enterprises in IT and business strategies. The organization also offers certification programs for professionals to validate their expertise against globally recognized branches in areas like IT architecture, enterprise management, and more. If your company use Microsoft software, which most companies do, so if you are a mainly Microsoft company, Microsoft is a great source of reference for zero trust. As a matter of fact, Microsoft has all the components necessary to implement a zero trust network. Microsoft's zero trust model represents a shift in enterprise security philosophy, advocating for rigorous verification of all access requests within an IT environment, regardless of origin. This approach is guided by three fundamental principles: verify explicitly, apply least privilege access, and Assume breach. The verify explicitly principle mandates comprehensive authentication and authorization for every access request, integrating strong identity checks, usually via multi-factor authentication, and scrutinizing device security to ensure they meet predefined compliance standards. Least privilege limits users and device access rights to only what is necessary for specific tasks, reducing the potential impact of a compromise. The assume breach mindset encourages organizations to operate as if their network is already compromised, emphasizing rapid detection, response, and mitigation strategies to limit the damage. Key components of Microsoft's Zero Trust framework include Identity and Access Management, IAM, which utilizes Azure Active Directory to manage user identities and streamline access with robust security controls like conditional access policies. Endpoint management through tools like Microsoft Endpoint Manager ensures device security before allowing network access. Data protection is managed through Azure Information Protection, which classifies and encrypts sensitive information. Additionally, network security is enforced through segmentation and virtual perimeters, reducing lateral movement and exposure. Supporting these components, Microsoft integrates security information and event management, or SIEM, via Azure Sentinel, which provides advanced threat detection, proactive hunting, and responsive capability across the enterprise. Automated security responses powered by AI and automation tools help in dynamically addressing threats and reducing response times. Implementing zero trust with Microsoft involves a phased approach, starting with critical areas like identity, endpoints, and data, and expanding into infrastructure and applications. It requires collaboration across departments and continuous evaluation of security controls to adapt to evolving threats and organizational changes. This comprehensive strategy underscores zero trust as a continuous process integral to securing modern digital environments against sophisticated cyber threats.